We are happy to be back with another informative unit. If you want to add more to your knowledge of power system, this is what you want to follow. Before starting with our Unit 2, please make sure that you have watched and completed the first unit. That way, you will be very much comfortable with the content of Unit 2. Hydropower plant. The generating station that uses the potential energy of water stored at higher ground level for generation of electrical energy is known as hydroelectric power plant. Hydroelectric power plant is constructed in such an area where the construction of dam is preferable and wider reservoir is obtained. In construction of dam, water head creation is the main factor. The working principle of an hydroelectric power plant is such that the blades of water turbine receives water through penstock, and the potential or hydraulic energy is converted to mechanical energy at the turbine shaft. As the alternator is coupled with turbine, the mechanical energy gets converted to electrical energy. An hydroelectric power plant has got its own advantages and disadvantages. The advantages are flood control, storage of water for irrigation, clean as no ash or smoke is involved, running cost is small, less starting time, and robust and longer life. The disadvantages are high capital cost and high cost of transmissions. Schematic arrangement of hydropower plant. Dam is constructed across a river, and water from the catchment area collects at back of the dam to form a reservoir. A pressure tunnel is taken off from the reservoir and water brought to the valve house at the start of the penstock. The valve house contains main valves and automatic isolating valves. The former controls the water flow to the powerhouse, and the latter cuts off supply of water when the penstock is about to get damaged. From the valve house, water taken to water turbine through a huge steel pipe known as penstock. The water turbine converts hydroelectric energy into mechanical energy. The turbine drives the alternator, which converts mechanical energy into electrical energy. A surge tank, which is usually open from the top, is built just before the valve house and protects the penstock from being damaged in case the turbine gets suddenly closed. Governor opens or closes the turbine gates in accordance with the change in electrical load. If electrical load gets increased, the governor opens the turbine gates by some angle, and if electrical load gets decreased, the automatically governor will closes by some angle the gates, which is known as wicket gates, by some angle. Then from the powerhouse, electrical energy is transmitted to the station, which is located above the station, and from there to the transmission lines. Site selections. The following factors has to be taken into consideration while selecting the site for building or constructing a hydroelectric power plant. Availability of water, storage of water, types of land, transportation facilities. Main parts of hydropower plant. In order to best understand the hydroelectric power plant is divided into three main parts: hydraulic structures, hydraulic turbine, and electrical equipments. First, hydraulic structures. The dam, surge tank, penstock, headwork, and spillway. Dam is the structure which is built or created using stone masonry or concrete to store water and create waterhead. After completing survey and topography of the land, the type and site can be selected. Before selecting the site and type of the dam, the following parameters has to be taken into consideration. First, foundation condition, local material and transportation available, occurrence of earthquake. Spillway. When the river flow exceeds the storage capacity of the reservoir, in such a situation, the surplus water has to be discharged. So that is why spillways are used. Headwork. The headworks consist of the diversion structures at the head of an intake. They generally include booms and rocks for diverting flood debris, slices for bypassing sediments, and valves for controlling the flow of water to turbine. The flow of water into and through headwork should be as smooth as possible to avoid head loss and cavitation. For this purpose, it is necessary to avoid sharp corners and enlargement. Surge tank. Surge tank is like a reservoir, but small in size. It is built at the beginning of penstock. Surge tank should be of open type, so there is no need for pressure control. Penstock. Penstock simply is the carrier of water to turbine. It can be of open, closed, reinforced concrete, or steel type. Various devices such as automatic butterfly valve, air valve, and surge tank are provided for protection of penstock. Automatic butterfly valve shuts off water through the penstock immediately. Air valve maintains the air pressure inside the penstock equals to outside atmosphere pressure. Water turbine. Water turbines are used to convert the energy of falling water into mechanical energy. There are main two types of water turbine. One, impulsive turbine, and second, reaction turbine. First, impulsive turbine. Such turbines are used for high head. In an impulse turbine, the entire pressure of water is converted into kinetic energy in a nozzle, and the velocity of the jet drives the wheel. The example of this type of turbine is pelton wheel. It consists of a wheel fitted with elliptical buckets along its periphery. The force of water jets striking the buckets on the wheel drive the turbine. The quantity of water jet falling on the turbine is controlled by means of needle or spear placed in the tip of nozzle. The movement of the needle is controlled by the governor. If the load on the turbine decreases, the governor pushes the needle into the nozzle, thereby reducing the quantity of water striking the buckets. Reverse action takes place if the load on the turbine increases. Second, reaction turbine. Reaction turbines are used for low and medium head. In a reaction turbine, water enters the runner partly with pressure energy and partly with velocity head. The important type of reaction turbines are 1. Francis turbine, 2. Kaplan turbine. A Francis turbine is used for low and medium head. It consists of an outer ring of stationary guide blades fixed to the turbine casing and an inner ring of rotating blades forming the runner. The guide blades control the flow of water to the turbine. Water flows readily inwards and changes to a downward direction while passing through the runner. As the water passes over the rotating blades of the runner, both pressure and velocity of water are reduced. This causes a reaction force which drives the turbine. A kaplan turbine is used for low head and large quantity of water. It is similar to Francis turbine except that the runner of kaplan turbine receives water axially. With that being said, we have arrived to the end of this video. Thank you so much for watching. Bye.